transformer and winding insulation. When you design a power transformer, you should also think about winding insulation. Here we will simulate electric field distribution in the insulation of the oil immersed transformer. The insulation material at the end winding is often subjected to higher stresses, so we will simulate only part of the winding. Insulation includes oil, press boards and oil paper. All these materials feature different electric permittivity. My task here is to calculate electric field stress distribution in the oil gaps. To calculate electric stresses, it is enough to run electrostatic analysis, but I will run AC conduction analysis. This way you can specify alternating voltage and calculate displacement currents. Okay, let's start QuickField now. In QuickField I create new problem. Problem name winding. Next. Problem type is AC conduction. Frequency is 50 Hz. Length units are millimeters. Model class is plane parallel. Model thickness is 100 millimeters. Finish. On the left you can see the problem pane, and on the right you can see the geometry model editor window. Here you can draw the geometry model, or you can import the geometry model from the .dxf file. .dxf file is used by the majority of CAD programs to exchange two-dimensional geometric models. I already have the model prepared, so I will import it. The model is imported. Now I should assign labels. Through labels I will specify material properties. Switch to select objects mode. Click the object to select and type in the label name here. This is oil. You see the label appeared in the tree. You can also use the rubber band to select a group of objects. For example, I will select this group and assign the label press board. Okay. In fact, not all these blocks are press board. These two blocks are winding. To select multiple objects, hold the control button pressed. Okay, I assign label winding. And the winding is insulated with the oil paper. I need to zoom in. Switch the zooming mode off. Click here. Hold the control button pressed to select another block. These blocks are oil paper. That is all for blocks. Now let's assign labels to edges. Zoom to fit. Top edge belongs to the core. It has 0 electric potential. It is grounded. So I assign the label grounded. Left edge belongs to the core leg. It also has the 0 electric potential. So I assign the label grounded to the left edge. And the right edge belongs to another leg of the transformer. It is also grounded. Now let's zoom in. These edges belong to the static end ring. So I will assign label static end ring. Static end ring. And these edges belong to the winding. I select them and assign the label high voltage. Now I should specify physical properties. Double click the label in the tree. and type in electric permittivity of oil, which is 2.2. Electric conductivity is very low. I'm not interested here in the leakage currents, so I set the conductivity to be 0 for all the electric materials. Okay. For the oil paper, I specify electric permittivity of 3.5, and for the pressboard, I specify electric permittivity of 4.5. I'm not interested in the electric field inside the winding, so for the winding I do not specify any properties. You see now the label has the exclamation mark. This means that no field will be calculated in these blocks. Okay, for the grounded edges I specify 0 electric voltage. High voltage winding electric potential is 200 kilovolts. That is root mean square value. In QuickField I should specify peak values, so I multiply this by square root of 2. Okay, and the same electric potential I assign to the static end ring. Okay, now that's all. I have only to build the finite element mesh. Just press this button, save all problem files, and run the analysis. The problem has been solved. Let's take a look at the results. Here you can see electric potential lines and the color map of electric field strength. The legend displays the correspondence between the colors and numbers, and you can get exact values. Use the local values tool, click any point, and here you will get the potential value and the field stress. In the composite oil solid insulation system, the strength of the insulation is determined by the strength of the oil gaps. The solid insulation is used only to subdivide long oil gaps into smaller ones. And I can use the contour tool or the contour line here to get electric stress distribution along this line. Okay. I can draw the contour in any place, but I would like to draw the contour along the field strength line. On our website you can find the electric field lines free tool. Let's download it. Open the file. Yes, run the file. This tool helps to build the integration contour along the field strength line. You need only to specify the start point position. Let me check. Click here. Here are the coordinates. 0.102, 0.1975. I should also specify the contour direction, the segment length, let it be 5 millimeters, and the maximum line length, let it be 15 centimeters. Now I click plot the line, and you see the line is constructed. I can open the XY plot to see the electric field strength distribution along the E line, and I can get the exact values in the table. Coordinates, electric field strength components. Okay, we have completed the analysis of this configuration of the end winding insulation, and we have located some hot spots which you would like to eliminate. It's easy, you can modify the geometry model in QuickField. In fact, the angular ring should follow the electric potential lines. So maybe I need to move this pressboard a bit higher. Okay, open the geometry model, switch to select objects mode, select the press board, hold the control button pressed to select multiple objects at the same time, and let's move it a bit higher, like this. All labels remain intact. You can check this is oil, this is oil paper, this is the press board. So I need only to build the fine alignment mesh, save all problem files, and run the analysis again. And again I can take a look at the results. Again I can use the plot electric field line tool and plot the E line and see the electric field stress distribution on the XY plot. You can use the contour tool to select blocks and calculate volume integral values. For example, I will clear the contour, click here and ring integrals, electric charge, and if I divide the electric charge by the potential difference, I can get the capacitance. You can also adjust the field picture and choose the values to display. For example, I will switch off the color map of the electric field strength and switch on the vectors of the displacement current. Okay. Right now I do not see vectors. That's because the current is varying in time. You can adjust the phase and the picture would change, and I can switch on the animation. Now here you will see how the electric potential and the current varying in time. If you search for the end winding insulation, you will find the example page on our website. Here you can read about problem setup, browse the solution section, take a look at the resulting pictures, and you can download the simulation files here. Simulation files may be opened and the results may be viewed using any QuickField edition, including QuickField Student Edition, that you can download from our website for free.